Hey everybody. We are going to talk about Messenger, the Messenger component. So you've been sort of teased yesterday by Fabian. There was a revolution and all of that. So I'll try to make it a good talk and make it understandable. First, very quickly, introducing myself. My name is Samuel Roze. I'm working for Birdie, who's an healthcare startup. I'm core team member of Symfony, working on also the two projects that are continuous pipeline tolerance as open source things. The second one is a continuous deployment pipeline for Docker containers, if you're interested, and tolerance being more how we can sort of have architectures of different services that talk to each other, but like things like retrying requests and all that. Birdie is an healthcare startup, as I mentioned. We are right now in the UK trying to help the elderly to age better. It's a very, very interesting project. If you actually look at birdie.care, it's very nice. So, Messenger. My clicker doesn't work anymore. So, what is Symfony Messenger about? So there are a few concepts I'm going to walk you through, and then give you some more indications on how the stuff works under the hood. So the first concept is messages. It's just your own message. So if you're into different buses or different CQRS and all these kind of things, it can be your queries or your comments and things like that. It's just a PHP object. There is no contract, nothing. Then you've got this message and you need to actually send it to a bus. So that's just where you dispatch your messages. On the other side, the bus actually knows how to call something, which is your own business logic, and that's called a message handler. So you can have multiple handlers for a given message, or 0. That's already enough in terms of trying to organize an application around the bus, so you can properly decouple your application in different modules, and you can actually have a very nice way of really structuring. Now, there is this other concept, which is the transports. So the idea being we dispatch the message to the bus, and it calls one or multiple handlers. That is going to be completely synchronous, so it will directly call the handlers, except if you actually configure the bus to route the message somewhere else. And the somewhere else is actually the transports. So they are responsible of receiving messages or sending messages to things. Typically, that can be RabbitMq, but it can be so many other things. And the last sort of concept is the worker. The worker is just the thing that actually is going to ask the message to the transport and send it back to your handlers while it's somewhere asynchronous. Does that make sense? Yeah. Fantastic. The same idea in graphs, because we love graphs. We dispatch a message to the message bus that is handled by 1 or 0, 1 handlers. Then the message bus can actually decide, no, I won't call the handlers right now. I will actually send the message to X transport. As I mentioned, the transport are responsible of talking to these things. And in order to get the message back to the handler somewhere, we have this worker that receives the message from the transport and sends them to the message bus. That's it. That's the main concept. So let's look at some code, right? So the first thing you need to do in order to use the messenger component is composer require Symfony/messenger. You can also use composer require messenger if you use Symfony Flex, because we've got aliases and all that. But it works really as a component as well. A message is really just your PHP class. It's your message. So it means there is no class, no abstract class, there's no interface, there's nothing. It's just your thing. So we're going to take an example for the beginning of the talk, which is sending notifications. So we decide that we actually need to send a notification to a set of users. The way we're going to design our message is just that PHP class. Now, if you look at the message bus component as a component, so without sort of the Symfony framework application, that's basically how it looks like. So the bottom is the creation of the message bus. And you can see that actually a message bus is created with some things. Actually, the source code of the message bus class is probably 20 lines, maybe actually 10 lines if you remove all the comments. There is no real logic. The main point is actually in the handlers, in the middlewares. So the middlewares are things that are going to be called every single time you dispatch an event to the bus. One of them, needs to be the last one, I guess, is the middleware that will actually call your handler. That's that example. You can see the handler here, that anonymous function. There's the same principle with the message, no trying to put no restriction on the user land code. An handler is just a PHP callable. That's it. So that's how it looks as a component. Turns out if you use Symfony, the sort of like application, you don't need to do anything. When the Messenger package is actually installed, the Symfony framework bundle will automatically create an instance of the message bus for you, so you can inject it in whatever things you have. So that's kind of like how it would look like. That's a beautiful controller that has a few things. So the thing you can see is that we inject the message bus interface directly in the action. That's new from like Symfony 4.1, I think. But the main point is we actually get the bus and we dispatch our object, send notification that we've created just before. If you do that, then you're going to see this beautiful exception. By default, you need to have an handler when you actually dispatch a message to the bus. We'll see later in the talk that we can actually tweak that, but by default, that's the behavior. So the next step being, we need to create the handler. So that's how, again, it's a PHP callable. So the tweak or the trick to do that in a class-based approach is to create a class with an __invoke method, which makes it a PHP callable. So your handler basically takes your message and do whatever you want with it. Again, no restriction on that. There's a slight thing here. So you create the handler class, but you need to register it. So the old nice days of writing things in the services, the YAML or XML, that's how you could do it. So you can create a service with a tag messenger.messageHandler. Symfony will actually automatically look at your type int on the invoke method and just register your handler for that given message. You've got another way that you can register the handler as well. The option 2 is to use this PC4 sort of like loader thing. So you can actually decide that every single of your class in the source message handler folder needs to actually be needs to be tagged with the messenger.messageHandler tag. It's another way. But you've got a third way as well. The third way is to use this message handler interface. So there is actually an interface for the handlers, but it contains nothing. And it's completely optional. The reason for that is actually, there is this very nice feature in Symfony now, which is auto-configuration. So it means that every single time that Symfony sees a service with that interface, it will automatically create the tag messenger.messageHandler. So it actually does mean that if you actually have an handler with this interface, you don't need to have any single configuration in your services, .yaml or anything like that. That's the best option. That's the simplest one. So if I take that same example, run it, that's sort of like how it looks like. We have an echo in the handler, fantastic, just display, and we've got the OK, which comes from the response of the controller. As simple as that. Now, that's what we've done. So that's just dispatching the message and being handled by the handlers. That's the graphic representation of what we had. Now, let's take the example where that sending the notification actually calls an API, and it calls, I don't know, Firebase push notification things. Turns out every single call is 500 milliseconds. Therefore, if you actually send the notification to X users, it's super, super slow. So you need to do that sort of like not now. So we take this example here. We need to send a lot of notifications, 50 users, and it takes ages. So the idea is to say we can actually we can decide that needs to be done in the next second doesn't need to be done really right now. We can return the response to our user, but do this notification thing in the background. So that's the idea of like asynchronous. That's where we introduce this other thing, which is routing the message to the transports. Really, that's not something you need to do. It's something you can do. So the idea is that you have a very nice migration path, and you start with your message. You start with dispatching your message, creating your handler. Everything is synchronous. It's fairly easy, no operational overhead. And then, if you have some performance problems, or if you actually need to have something that behaves a bit differently, then you can tweak it to be asynchronous and use the transport. So, what's a transport? It has a sender and a receiver. You probably guessed it. He sends and receives messages from things. It is configurable via DSN. You've seen that actually yesterday morning already. But the idea is to do the same thing that what Doctrine is doing for the database. So we migrated towards like a database URL string to have a single string that configures both the type of the transport, so MQP, HTTP, whatever, and then the credentials to connect to the thing. So everything is configurable using a DSN. And it uses a messenger serializer. That's one important point for like transport, because it means we actually go outside of the PHP process. We need to serialize the object. So it uses a messenger serializer, which by default uses Symfony serializer. But you can also tweak it. Within Symfony, right now, we've got just one built-in transport. That's the MQP one. Using PHP's MQP extension. We've got also a sort of community transport, which is using ASYNCHRONOUS. It's another PHP project which is really into connecting as much as possible of queues or message transport. So if you've got SQS, if you're using Google PubSub, if you're using Kafka, all of that, you can actually use the ASYNCHRONOUS adapter or the ASYNCHRONOUS transport for that. But it is also extremely extensible. So the only thing you need to do if you want to create a new transport is to implement a transport factory interface. And you've got two methods, which is basically saying, do you support this DSN? And the other one is, can you create the transport for this DSN? It's very easy. We may have another transport in 4.2. There is a pull request for a Redis transport. There is enough interest, we might go ahead with that. But we don't know. Right now, it's just MQP built in and the ASYNCHRONOUS transport. So how you get into like using it? So the first step being configuring the transport, registering the transport in the messenger component. I mentioned the DSN. Here's an example here. It says I'm using the MQP transport, and this is basically what I'm going to do. It's RabbitMq running locally, using the message exchange and queue names. That's it. Then you create a transport. Here you create a transport that is named default. There's no magic thing around default. You just give it a name from that DSN. And that's it. Now, if you just rerun the application, the same application with just creating the transport, you won't do anything. You need to explicitly route the message to the given transport. So here we say, well, actually, all the messages send notification. They need to go through the default transport. That's it. It can actually be here. You can actually put an abstract class or a parent class. It can be an interface. That's up to you. And then we rerun the application, and super fast. Yeah. But actually, nothing happened, right? We just send the message to RabbitMq, and then that's it. So that's where the last bit comes in. That's the worker part. So it means asynchronous. It means you send the message somewhere. You need to have the worker. You need to have something running somewhere else that is going to listen to these messages to do something about it. That is the command that you can use in order to consume the messages. So it's something that is going to register via the transport to wherever you push the messages and be called every single time there's a message. So we take the same example, we actually run the command and then it does all the work. And that's it. That should be it. There's more things, but that's the aim being that on the user perspective of it, as in like our developer experience, is just to care about this. Create a message, create a handler, and then route it to a transport if needed to be. Now, there are other opportunities with that. So buses, you can, if you want to, create multiple buses, right? If you're into, like I mentioned already, the CQRS, or very into what Fabian's mentioned as like all these design pattern things, you can create multiple buses if you want. So that's basically how you do it. These here are just the name of the services that are going to be created. So it actually means it will create a common bus service, which is an instance of the bus, and an even bus service as well, that you can inject in various different things. While we are at the multiple buses, it actually turns out that if you create multiple instances of them, how would the auto-wiring thingy know which bus it needs to inject? So that's where there is a lovely auto-wiring trick. So I'm not sure if you know, but there is this bind thing that you can configure either in the default of the services or per service. But you can actually say, it's mostly used for parameters usually, mostly like an API key or something, with like scalars and things like that. But you can say the parameter that is named even bus will receive this value. And actually here we say, well, every single thing that is named, every single parameter that is named even bus will actually return will get the even bus instance of the bus. You can also, before here, you can also put the interface if you want to. You can put the message bus interface to being more strict about how the bind will work. So that's how you can still have auto wiring with multiple instances of it. Now, that's exactly what I said. You can have these multiple instances on the same class. There is a fourth way of registering handlers. Hey. The fourth one is another interface, which is called Messenger Subscriber Interface. If you use the event dispatcher, same principle. You've got a listener, just one event. Therefore, an handler, just message handler interface, just for one message. The subscriber can actually say, hey, I want to subscribe to this message, and maybe call this other method. And you've got also the opportunity to also listen to only one bus. So that way you can actually see that here, we actually just subscribe for the send notification object, or message, on the common bus, and we will actually call the do something method. A nice note about why yield. That could not be possible without the yield. If we use the array, like what's in the event dispatcher thingy, for example, we will not be able, in a simple way, to configure multiple sort of like subscription configuration for the same exact key or the same exact message, my message thing. So that's the interest of using the yield. And that looks quite cool, no? So middlewares. So I think we're done with the handlers. Promise there is no other way of configuring any of them. Now middlewares, which are really the core logic of every single bus. You can create a middleware yourself, and it looks like that. It is a class that implements the middleware interface that has just one method, which is handle. It takes the message, and it needs to call the next middleware. That's it. So you can take an example here of an audit middleware. If you really want to, here we just echo something, but it can send to whatever auditing trail you have or anything. Here it will display a message that says, I've started with the message X, call the handler, here, and then says, yeah, I just finished with the message X. So that's using this next thing here, that's how we can actually execute some logic before and after the handler is actually executed. And the reason the handler is executed is because one of the next here, one of the last middleware is actually just calling the handler. Yeah? When you've created your middleware, you need to sort of explicitly configure it or attach it to a bus. So that's how you could do it. So you're going to say the command bus middleware as the audit middleware. That's it. Now, there's one more magic thing, which is called the envelope. I believe that's the greatest bit of the Messenger component. That's very an interesting concept. The idea is to say, from the beginning, you need to only put your own logic in the message. So there's no flues about like parent classes or all of that. So just your thing. Turns out, when we start to use asynchronous processing and we start to actually distribute things somewhere else, there's much more context usually that needs to be brought in with the message than just necessarily what you have in your application. It can be tracing, it can be auditing, it can be IDs that you need to fly around to know exactly what's going on in your system or these kind of things. So the idea is to say, we are going to create this concept of the envelope, which is something that is around the message on which we can attach non-domain things, so really things that are technical and not really interesting in our domain, in our application. That's the main thing. So when I show you an example from the middleware, how instead of getting the message, you can get an envelope. So the magic here is just the envelope-aware interface on top of the actual middleware interface. And it means that here, this parameter is not the message anymore, it's the envelope, which obviously contains the message. But what it means is a very interesting thing happens. Here we see an example where the middleware, because if you consume the message and you actually, when you consume the message goes through the bus as well, again. So maybe you've got this like question that is how it is configured so that it doesn't just loop. Just like gets from the queue, go back to the bus, and then go back to the queue and all of that. The way it does that, it's using the actual envelope, and an envelope has the message and envelope items. There's one envelope item that is used in the Messenger component core, which is the item that says receive the message. So it turns out that here in your auditing logs, you can also, using the item or by detecting whether the item is there or not, you can actually know whether the message was consumed or it was just dispatched. Non-domain things, so that's really more logic around how you transport the messages. What you can also do is to create your own envelope item. And I'm going to use the exact same example of the auditing purposes. When we have a request that sends messages that are handled later, that probably these things also send messages that are handled later, in order to know what's going on later, something happened, it's super, super complex because you don't necessarily know who triggered the message and all of that. A way you can do that is associating IDs on the messages. So that example is saying we are going to create our own audit envelope item. So we're going to push on the envelope every single time we dispatch or receive the message, so that we've got a consistent identifier for the given message, both when we dispatch it and both when we receive it. But it's not part of our message class. It's the main point. Does that make sense? I hope so. What it actually means is just same trick. We create our own middleware with the envelope-aware interface. We get the envelope, we get the message from the envelope. And what we can do is we say, well, if there is no audit envelope item, I'm going to just create it. So I'm going to create a new envelope with the new audit envelope item with our generated UID or unique ID, whatever, our identifier. So it means it's just created once when we dispatch it. And then now what we can actually say is to call our getUID method on our audit envelope item to get the ID of the message, and it will be consistent across our different processes and execution. And another audit envelope item, same principle, there's nothing fancy about it. It's just your PHP class. It needs to be an interface. It needs to implement this envelope item interface, but it doesn't contain anything. So it's up to you. The trick, obviously, that it needs to be serializable as well. The envelope feature is also used for configuration. So there are things like sometimes when you dispatch a message, you may want to dispatch it with a special MQP configuration, whatever, different routing keys, something like that. Or you actually want to serialize the message in a particular way. So that's how, using, for example, the serializer configuration envelope item, you can configure how, for a specific message when you dispatch it, you can configure it, which serialization groups the Symfony serializer used by the messenger component will actually serialize the message. So you can actually have lightweight messages if you, for like whatever reason, if you need to. That's the idea. So what can you do then? You can try it. It is experimental in 4.1 and now stable in 4.2. It means we almost didn't break things between 4.1 and 4.2. Just few changes in some interfaces, mostly internal. So I'd say you can also already try it in 4.1. You've got very low risk of getting into trouble when you upgrade to 4.2. And 4.2 being very, very soon now, that's fine. You can help us. Wow, that was fast. You can help us make it great by trying it. And opening issues, pull requests would be very welcome if you've got a transport that doesn't exist and you actually believe that would be fantastic. I'm thinking transport a bit creative, like for example HTTP. What if actually when we dispatch a message to the bus, we've got an HTTP transport, and then it will actually just call an API. Things like that. I'm pretty sure we can actually come up with very nice way of architecturing this messenger bit, and yeah, and enjoy it. And that's it. Thank you very much. What kind of questions do you have?
You didn't talk too much about consuming, but when you consume a message, if the worker was to experience some kind of crash or something, is there some way to, say, claim that you're working on a message and then like commit and say that, yes, I processed as well, before it gets plugged off into the queue?
So at least the MQP transport, because that's completely down to the transport strategy, obviously. The MQP one, it is a sort of like, it's a manual acknowledgement. So it will actually manually acknowledge the message to RabbitMq only if the handler worked the actual, like, when I dispatch to the bus, and it will only acknowledge when the bus has finished to call all the handlers.
But if it's I'm thinking the asynchronous case where you run the console connect.
Yeah.
Is there a risk where you take a message off the queue, the transport gets it, and then as you were doing some processing, that got an exception or failed, and then you would want the worker to catch it again and like to.
So by default, if the bad scenarios of like it doesn't work, by default it will requeue the message.
Okay.
So that's the default behavior, and you can actually make it so that it rejects the message if the exception you throw implements a given interface that is given by the messenger component. Yeah.
Is that a dead letter queue? Are you guys requeuing it?
No, just requeuing for now. There is a pull request that I hope to get merged before the end of 4.2 about retries. So that would actually include like dead letter queues in order to like have with the timeout so that it gets back to the queue after X attempts, or just stay there.
Like the scenario where you want to replay it and you think 5 times.
Exactly. Yeah.
Yeah, like if this is like the email sender,
Exactly.
you get an email and then the transport for email fails.
Yeah.
You would like it to be left on the queue for the worker to come back to.
Exactly. So by default it will be retried, but very likely in the next 100 milliseconds. But there is, so there is a pull request. Your feedback is actually welcome if you're really interested in these things, into getting the retries as well. Any other question? Fantastic. Thank you, Ben. And actually, one thing I didn't mention, for whoever is actually living in here in San Francisco, there is a Symfony meetup. So you could actually just talk to this guy here and join the actual Symfony community if you want to.
Yep. Many things to share. I mean, if you want to share something, some tips, trick, experience, bug, anything, just come to see.
Come there.
Organize something.